So we will have a quiz on Tuesday on acid-base stuff. So if you all come in on Tuesday and say, what? I didn't know we were having a quiz, we can go back to the video. You know, I told you. Quiz on Tuesday on acid-base stuff. And these last few chapters really don't, unlike some of the other ones, they really don't rely on each other. So we're going to talk about nuclear chemistry, then we're going to go into organic chemistry, kind of all separate, which a lot of people really like because they'll feel like this is stuff that they can just get as one piece and not have to go back and think about all the other things and how it works into it. So most people like these upcoming chapters. We've only got 2 chapters left. Well, 2.5. There's a little extra bit at the end, but basically 2 chapters left. One small one, which we'll talk about today and Tuesday, nuclear chemistry, and then the big one, chapter 11, organic chemistry. But, you know, not a whole lot of math in those chapters, so people tend to like them. Yeah.
About the last question on the first.
Yeah.
You said the water is good to know
Good question. So the density of water is 1 gram per milliliter. So every milliliter of water weighs 1 gram. So if you have 50 milliliters of water, you have 50 grams of water. Okay. Let's look at nuclear chemistry. How is nuclear chemistry different from other kind of chemistry, regular chemistry? What's special about nuclear chemistry? You know?
Sounds exciting. Something with energy.
Sounds more exciting? Something with energy?
Yeah.
Sure.
Radiation.
Yeah.
In a lot of cartoons.
It's in a lot of cartoons.
Aren't you specifically targeting like anything that's to do with radiation?
We'll talk a little bit about radiation, but more generally, those are all fine. More generally, we're just talking about chemistry of the nucleus. What's the nucleus? The center of the cell? Yes, that's what we're talking about, cells. Let's specify that then. Chemistry of the atomic nucleus.
Is this chapter 17?
This is chapter 5. We skipped that one a long time ago. Now we're going back. If you have the old book, it's the next chapter in line.
Right.
If you have the new book,
For
you
this
go all
book,
the
the
way
new
back.
book is 5?
The new book is 5, yeah.
Right. Exactly. Oh, there you go.
So it's the chemistry of the atomic nucleus. What is the atomic nucleus? The center of the atom. What's in there? Not DNA. Right, close. Yeah, there we go. So the atomic nucleus is the protons and the neutrons. So that's what's so different about nuclear chemistry from what we've been talking about so far. So far, what part of the atom have we been focusing on for the last couple months? The electrons. They're the things that are connecting these atoms to each other. Sometimes they get lost, sometimes they gain more, sometimes they connect or disconnect. That's what's controlled everything we've talked about so far and everything we'll talk about after this chapter. But in this chapter, you gotta get rid of that black, like dark thing up there. I don't know what that's all about. But in this chapter, we're talking about the inside of the atom, the nucleus of the atom, and that's going to be kind of different. So the things that happen inside the atom are totally different from the things that happen with the electrons. We're not going to talk about different kinds of atoms coming together and forming bonds. We're going to talk about nuclei disintegrating and giving off particles or being hit with other particles and then doing things because they're being hit with other particles. So a very different sort of way of looking at things. And we're going to talk about the different types of ways that these happen. First, just a couple definitions. So as you said in this chapter, we're going to talk a lot about radiation. What is radiation? How do you think about radiation?
Heat that can kill you.
Heat that can kill you. Okay. Other thoughts? Has anyone heard this word before?
Yeah.
In what context?
When I go
When you go to the doctor?
Hospitals, X-rays.
Hospitals, X-rays.
X-ray.
Mhm. Yeah, so really radiation is very, very general. And so we only hear about it when we're dealing with the types of radiation that can hurt us. But in fact, radiation just means any energy coming off of anything, or actually particles. So we'll say in very general terms, radiation is the emission of energy and or particles.
Everything is some type of form of radiation, just.
Right. So
something
like
doesn't
our
hit.
lights, any kind of light, fluorescent or incandescent or LED or whatever, is emitting energy. And it's emitting energy in the form of visible light. So we see that light, that's a type of radiation. Things that are hot emit infrared radiation. That's another type of radiation. Radio towers emit radio waves. That's a type of radiation. Our cell phones emit microwaves. That's radiation. And then radioactive isotopes, radioactive materials, which we'll talk about what those are in this chapter, emit other kinds of radiation. X-ray machines emit radiation. And then some of that is also in the term, so all of those examples have been in terms of just pure energy, but things can also emit particles. Like, I don't know if anybody here remembers back a long time ago, televisions and computer monitors used to not be flat, and they would be like big.
Yeah.
The cool one.
The cool ones, yeah.
I remember those.
It was like, what, 5 years ago or something, or not long ago. But you really can't get them anymore, I don't think. I mean, not
unless you have one.
commonly. Yeah,
To order them.
But
There's still really nice ones out there.
there are still really nice
Yeah,
ones.
like some companies do make them, they're really nice, but they're huge. So nobody
Yeah.
wants them.
Right. But why are they so huge? I mean, why did it take us like hundreds of years to go from this to this?
Because they had the big tubes, right?
Yeah, what's the
And
tube?
now-
You know? Why it's a tube?
Oh, the tubes have light and they emit some type of form of gas or light.
Yeah, it's called a cathode ray tube.
Oh.
A CRT, cathode ray tube. A cathode ray is actually not light. We thought it was a long time ago when it was first discovered, so it kept its name as a cathode ray, but it's actually a stream of electrons. So it's shooting a stream of electrons at a screen, and then as the electrons hit the screen, it lights up bits of the screen. So that's why it has to rasterize or like back and forth to shoot electrons across the screen in the proper way. So that's an example of particle radiation. It's emitting particles, emitting electrons. That's also how X-rays are generated. In an X-ray machine, you have a material that is excited so that it emits electrons, and then those electrons hit another material, and that releases X-rays. So that's how X-ray machines work. So you can have emission of energy and or particles. Most of that radiation, we don't even think of as radiation because like light, think of it as just light. But there's a subset of radiation that can cause some problems, and we call that ionizing radiation. And ionizing radiation, what do you think that means? This is the bad stuff.
It breaks apart.
Kind of. What does it mean to ionize something?
Electrical, like negative. Some high electrical negativity.
Okay. What does it mean? So usually, if you say something ions, like, what's another example of that?
Deionized water.
Acclimatize, deionize. If you like do something to ize something, it means that you are making it into something, right? Or changing it somehow. So if you're ionizing something, you're turning it into an ion. Right? Turning something into an ion. So ionizing radiation is radiation with enough energy to knock an electron off of an atom or molecule. So light, infrared radiation, when it hits molecules, it makes them vibrate, makes them change shape a little bit. When visible light hits molecules, it makes their electrons change energy a little bit. When UV light does the same thing, and then when higher energy light hits these molecules or atoms, it can actually knock electrons off. And if it knocks an electron off, it usually makes it very reactive. Remember how we talked about pairing up the electrons and octet rule and all that stuff? So you're kind of knocking one electron out and making something really unstable. And when that happens, it's likely to react with other things that it may not be supposed to react with. So ionizing radiation might knock an electron off of your DNA, causing your DNA to react with itself and cross-link in a way that it's not supposed to, kind of link with itself or link a couple things together that aren't supposed to do it that way. And that's how these can start causing problems, because it can start no longer, then your DNA isn't going to do what it's supposed to do anymore because it's not in the right shape or the molecules aren't in the right position. Yeah, so then you have mutations and things like that.
Like skin cancer?
Right, so ionizing radiation causes cancer in a lot of cases when you're overexposed to it. Not just in your skin, but in any organ that is exposed to the radiation because of how it can affect the DNA.
How can you be exposed to it?
Well, I'm glad you asked that, because we will go through all of that in a moment.
What kind of treatments are out right now to like help with people who are exposed to lots of radiation? Do we have any just
No, not really. I mean, the answer is it's supportive. So the damage is done, and then whatever that damage is going to cause in terms of cancer or whatever else, you can try to support and treat that.
So if radiation would cause a mutation, like say skin cancer, why would they then use radiation? Do they then radiate the cancerous cells and
Right.
knock another?
Right, so the radiation causes damage. That can be damage to things that you don't want damaged, and that can be damage to things that you do want damaged, like cancer cells. And there is, yeah, and so we'll talk a little bit about that. That you can direct it physically, like put some radiation here or here. You can also direct it kind of physiologically, because radiation tends to ionizing radiation tends to negatively affect rapidly dividing cells the most. So if your healthy cells are exposed to radiation, you're going to take that damage in things like bone marrow, skin, intestinal cells, liver, all these places where your cells are dividing rapidly. But then if you have cancer, the cancer is the rapidly dividing cells, and so you can target that a little bit also in that way. Yeah, good questions.
And how does iodine play into place with radiation? Why do they make some people drink iodine back in the days? I mean, how does that work? I don't see it.
Iodine?
Yeah.
Like radioactive iodine?
Radioactive iodine? Well, iodine is for your thyroid. It goes to your thyroid. And so if you have thyroid problems, like radioactive iodine, which goes to your thyroid, and the radiation destroys part of your thyroid, so that it's not overactive anymore. But iodine is an important mineral or ion that you need to supplement so that you have proper thyroid health. We get most of ours from salt now, from iodized salt.
I know it gives you like cancer over there, but does it affect like your skin sometimes too? Like too much radiation?
Right. So radiation doesn't only do things like cancer, but it can actually just burn things. It can just damage cells just from the energy transfer of that amount of energy getting into your body, just like heat energy or anything else could damage you. So you can get burns from radiation as well. The dangerous thing about radiation is, and we'll talk about this with different types of radiation, is it may not just stop at the top of your skin. So if you are exposed to high levels of ionizing radiation, it can burn you, but it can actually burn you kind of from the inside out, because it can get all the way to the inside of whatever, depending on what type of radiation it is. That can also be helpful for some reason, for some things. It's not only bad. We'll talk about that as well. But these are all good questions. Anything else?
Is there any truth to, like, I had a roommate and it's not,
there was some parent at college who kept warning us not to stand by the microwave or something. I don't know, it's just like overhyped fear, but.
Yeah, that's like I think that's a common, like your parents telling you not to stand in front of the microwave. My parents always used to tell me about that. It'll give you headaches or something. That is that's microwave radiation, which is non-ionizing radiation, but it can heat you up just like it heats the food up. So you don't want to be exposed to high intensity microwave radiation. If it's dangerous for you to stand in front of your microwave, it's because your microwave is leaking. And maybe it's old, it's not sealed properly or something like that. It should not, no microwave should be allowing microwave radiation outside of the unit itself.
You could actually get a meter to measure the electromagnetic field in your house, just in case there's any type of, I mean, I did a whole research paper on electromagnetic fields. So
Okay.
I only know certain parts of radiation, all of it, I mean, I'm going
It's
to
a
learn more
broad
here.
thing, yeah.
But I just learned radiation in the form of light, obviously, and from cell towers, et cetera. Like I had to do a whole research paper on how it affects the human body. So it was interesting. And then so the more I read into it, I'm like, oh my God. So then I went to like, the supply store and then I got all this bunch of stuff. But it was fun. I went around the house and it's like kind of, it's just like there's a dial and it shows you, and it's depending on the, there's certain,
Yeah, so you
I don't
can-
know off the top of my head, but it shows you it comes with a little paper because, nobody knows these numbers, and it tells you what is the average.
Yeah.
At certain levels. This is really cool.
And so there's a certain amount of background radiation that we experience, everything from the most dangerous ionizing radiation down to harmless radiation is always around us, coming from the earth and from space and from natural materials, and that's always going to be there. But yeah, so if you have a microwave, you can test if that is actually leaking microwaves, and it should not be. There should not be higher levels of microwave radiation.
So I talked to, like, you wouldn't be able to tell that just from the standpoint.
No, you
No.
no.
And I mean, the way those things are engineered, if you have any microwave oven that was made in the last, let's say, I don't know, 50 years, like it should not be
Right.
an issue.
So microwaving food is completely the same.
Yeah.
And not only that, the thing is that some houses are also old and not up to code. And the thing is, it's caused problems. Some people like hear the Henry comment, or some a long time ago they got sued because there was strategically it was built next to this really, really old post, and they refused to change it. And it was he kept on hearing this loud hum. I mean, everything inside the house, the infrastructure, I mean, the way the electrical circuits were, everything was extremely old, and it was causing him to get ill, and people thought he was crazy. So they decided to come in, and they tested it, and it was really, really high. Like
Yeah, so
higher
we're-
than the average. So they had to close the thing down, and it was
As a flight attendant, people used to, I mean, a lot of the other flight attendants and pilots and stuff have the little, it's a little medallion that tells you how much, because you're
Right.
up,
Right. So
so high.
an airplane trip does significantly increase your exposure to ionizing radiation. The higher you are, the more you experience from space. So if you fly more, you're exposed to more of that radiation
Yeah.
for sure.
It just freaks me out. I stopped wearing mine. I'm like, I don't even want to. I mean, what are you going to do? Quit your job?
Well, yeah. Well, and then if you work with X-ray equipment, you'll have a similar thing. So like I worked with a lot of X-ray analytical equipment in chemistry, and you have a badge and you have a ring
That's what
that
we
goes
do
in your
now.
finger because that's where you're messing with the instrument, and you send the thing in like every month, and they measure how much radiation you've been exposed to, and it should be like basically zero or very low.
Way too late if they find out you're.
Well, it's not, yeah, right, but at least then you know, and you can support, go to the hospital, start working on stuff, fix the machine so that other people don't have the same problem.
So do radiologists get more even when they
I mean, probably a little bit, but that's why they have all that stuff to minimize exposure. So we'll talk about these levels also. We've just gone through the whole thing just randomly here from questions. But there are pretty clearly set guidelines of like, this is a safe level of exposure per year. Make sure you stay under that. And so those people like that would be wearing monitoring badges and being tested. And so if that level gets too high, then you have to do something about that. Clearly somebody's not doing something right.
instantly kill you?
Yeah.
Depending.
Mhm.
There's a level.
Yeah.
That's awesome. I mean.
It's not really awesome.
Does they recommend women under 40 to get mammograms because of radiation exposure?
It's more that it's not necessary, that it's, I think, I don't know the whole medicine behind that, but I believe that they found that it doesn't actually,
They found, okay.
Do anything.
But back in the
Doesn't-
day, they
doesn't
say
prevent
boys
cancer.
have a lot of radiation.
right, so then I think this, right,
That's
that's what you're saying, is it's not actually effective in preventing cancers.
That's-
But that's also part of it. That you don't want to be overexposed to, every time you have an x-ray, you're being exposed to some radiation, some ionizing radiation, so you want to only do that if it's necessary. If it's necessary, then of course you want to do it, but I don't know if you've ever seen, like, way back when these things were first being invented, shoe stores would have x-ray machines, so you could put the shoes on and you could put your feet in there and see like how well your feet fit in a shoe. 'Cause, you know,
That's awesome.
Yeah. but you don't go through x-ray machines at the airports.
No. Well, as a flight attendant, but now I do, because I'm not in uniform, so when I fly.
No, but the like detectors that you go through, those are not x-rays.
No, now there are the.
That's different, that's backscattered x-rays, that's not the same, that's not ionizing
No, they
radiation.
detect none of.
If you were going through the thing that the luggage goes through, then you're being exposed to ionizing radiation.
So that thing that scans you, it's not.
Right.
Not
giving you
It's a metal detector.
2 seconds.
The thing that's just like a gate, that's just a metal detector. The
No,
thing that you put your hands
the
on,
one that had the
yeah, the thing that you put
scans.
the hands up, that's something called backscattered electrons. It's it does involve x-rays, but it's not ionizing radiation. It's actually measuring, well, it's measuring something that's coming off of you that's sort of like x-rays coming off of you.
I've never seen that.
Yeah, now they have it, they just scan like this.
Yeah.
And
They call them the X-ray machines, even though technically it's wrong, but it's like
It's
moving
a
an X-ray
really,
machine.
yeah, okay,
Yeah.
yeah, that's not any kind of.
Everybody's like, oh, the X-ray machine. I'm like, it's not an X-ray. Like, okay.
It is kind of,
But
yeah.
Is there anywhere on Earth that radiation can kill you instantly, or is that just in space? Like, is there any like high
They're in
level
space,
radiation?
yeah,
Radiation
you're
is killing
radio.
you.
You wanna
There are
watch
certainly
radio?
places-
It kills you.
There are certainly places in the US that are still radioactive enough from human
Chernobyl?
radiation,
Yeah,
Chernobyl, places like
yeah.
that. They can get you sick. There's no source of radiation that would kill you instantly.